was asked to give this presentation because many people are asking whether exercise has beneficial effects in PXE patients. So that's why, and we looked a little bit into this. This is quite preliminary data, but I think it's still interesting enough to share with you today. And before showing what we actually did, I will give a short introduction. Joni has already given some information about this, but the interesting thing about PXE, or maybe, yeah. Sorry, I thought my voice was loud enough now. Yeah, okay. That's better, probably. Yeah. So the interesting thing about PXE is that the lesions are found in the eyes, in the blood vessels, and in the skin, whereas the protein that is not functioning properly is found in the liver. So basically, PXE is a metabolic disease. And what does metabolic disease mean? It means that PXE is caused by the fact that something that's normally secreted by the liver cells into the blood circulation, a factor released by the hepatocytes, inhibits mineralization that's found in PXE patients in the eyes, in the blood vessels, and in the skin. And for long it was unknown what the nature of this factor was. And, oh, sorry, wrong direction. So then we did an experiment, and that was still done in Amsterdam, where we took livers of wild-type mice and of mice that do not have ABCC6, so the knockout mice that Joni also discussed. And what we did, we analyzed in what came out of these livers, whether there were molecules that were not present in the livers of the knockout mice, but were present in the livers of the control mice. And using this approach, we found that pyrophosphate was the most important molecule that we found in stuff that came out of livers of the control mice, but was very low in what came out of livers of the ABCC6 knockout mice. And then we also checked this in blood samples, because the liver provides many compounds in the blood. So it affects many compounds that are present in the blood. And we tested then in blood samples of healthy individuals and people affected by PXE, by the disease, and we indeed found that the levels of this metabolite, pyrophosphate, were lower in blood samples of the PXE patients. And at that time it was already known that pyrophosphate is an important molecule that prevents the precipitation of calcium and phosphate, so mineralization in connective tissue, so in eyes, in blood vessels, and in the skin. So based on this work, excuse me? So now we know that ABCC6, which is an efflux transporter, so this is a cartoon of a liver cell. We know that ABCC6 is present on the outside of the liver cell, and it pumps out a factor. It doesn't pump out pyrophosphate, but a molecule that serves as a precursor of pyrophosphate, but that's not so important. So it's important to know that it effluxes a compound that is converted into pyrophosphate, and this reduction in the amount of substrate for this enzyme results in a reduction of the amount of this inhibitor of calcification in the blood circulation of PXE patients. What is also important to know is that it's not zero. So people suffering from PXE still have some pyrophosphate in their blood circulation. And we thought, can we stimulate this? So it's not only that ABCC6 is not responsible for all pyrophosphate that we find in the circulation. So there must be other ways in increasing pyrophosphate in the circulation, in the blood. So we thought, can we stimulate these alternative ways to increase pyrophosphate in the blood circulation and maybe prevent the mineralization that's found in PXE patients. So this is some other work that I will not discuss today. This is about the bisphosphonates. That's another way of trying to increase pyrophosphate levels in the blood circulation, but that suffers from some side effects. Oral pyrophosphate substitution. My colleague Andras Faraday will talk about that, which is another way of maybe increasing pyrophosphate levels in the blood circulation and preventing disease progression. But something that I want to talk about is increasing pyrophosphate by stimulating alternative ways of getting ATP, so the precursor of pyrophosphate, into the blood circulation, and see whether that is converted into pyrophosphate and inhibits the mineralization that we see in PXE patients. And it's important to stress again that pyrophosphate levels in PXE patients are not zero, so there is room to increase it by stimulating alternative pathways, we think. And one way to do this was, and this is the whole idea presented in a scheme. So in healthy individuals, there is ABCC6 in the liver, and that provides ATP that is converted into pyrophosphate by another enzyme, and that accounts for approximately 60 to 70% of the pyrophosphate that is present in the blood. The other 30 to 40% is coming from ATP that is released into the blood via ways that do not depend on ABCC6. So these pathways, they are still present in PXE patients. So can we stimulate these pathways? So PXE patients only have these pathways, and therefore they have some pyrophosphate in their blood circulation, but it's just not high enough to completely prevent ectopic mineralization. So can we stimulate these pathways? Because if we can do so, we can increase the amount of pyrophosphate in the blood circulation, and maybe by that, in that manner, we can prevent disease progression. And it's interesting to know that also your red blood cells, they can release ATP. And released ATP can also be converted into pyrophosphate. So, and this ATP comes out of the red blood cells independent of ABCC6. And it was already described that physical activity might result in an increase of ATP coming out of erythrocytes. So we wanted to look into this a little bit more. And we first, because I'm a veterinarian by training, so we first wanted to test in horses whether if they do some exercise, whether the pyrophosphate levels go up. So the molecule that inhibits ectopic mineralization, does this molecule go up if horses do some exercise? And I won't go into detail, this just describes, so here on the right, the text describes how we collected the samples, but that's not very important, but I just wanted to show you how we did these experiments. So these horses did some moderate exercise. They first had a warm-up, and this machine that we use, or this equipment, is called an equisizer. I didn't know that, but very interesting name. And then after 5 minutes of warm-up, we had the horses trot for 20 minutes, moderate intensity, so this is really not something that was very difficult for the horses. And then they had a 5-minute cool-down period, and we again took a blood sample to see whether this metabolite that is very important for the inhibition of mineralization was increased in the blood of these healthy horses. So that I should say, these were healthy horses. And you can see from these bars, because we took a sample before of each of these horses, we took a sample, blood sample before and after exercise, and the molecule pyrophosphate that inhibits the ectopic mineralization, so the calcification, indeed went up after exercise. And this difference was highly significant, so it was a substantial increase. And we think this might also work in preventing mineralization in PXE patients, because other groups have found that you only need to increase the levels of pyrophosphate a little bit to prevent mineralization. So I'm not saying it's definitely going to work, because we really need to do some more work, and I will show you something. This will probably be a little bit difficult to see, because we want to test now in the ABCC6 knockout mice, so the PXE mice, if we exercise these mice, whether we can prevent the ectopic mineralization. Because we now know that exercise increases plasma pyrophosphate levels, but is the increase, is that big enough to prevent ectopic mineralization? So that's what we're currently testing. And we test this in the, is it working? So now we have, it's probably difficult to see, but what you see here is we now run PXE mice, and we're going to test whether if we run them every day, whether that prevents ectopic mineralization. And if it does so, then that is additional evidence that physical activity might indeed be a way to prevent disease progression. It probably will not reverse or I'm pretty sure it will not reverse existing lesions, but it might do something with the progression of the disease. So this is another way that we train the mice, and they seem to really love it. Let me see, because this is on the treadmill that I just showed you. There we have to keep them running, but here they can decide themselves whether they will run. So we put just a training wheel in their cage, and if you do so, they immediately start running. So they're really happy to do some exercise. So unfortunately, we don't have the results of these experiments yet, but we hope to get them in the next half year. And because these are long-term experiments, we have to train them every day, and then we have to analyze these data. Oh, yeah, you did see them, right? So I can show you if you like a little movie of it. There we go. There you go. So there it goes in, it goes out, and that's. So we now have very muscular mice. Okay, so some other things that we want to do next is, because now we found in healthy or unaffected horses that training increases the metabolite and that inhibits mineralization. But what's very important is to find out whether also in people affected by PXE, if they do some exercise, whether the levels of this metabolite go up. And we want to, together with PXE International, we want to do a small-scale study to see whether if PXE patients do some exercise, whether that also increases the abundance of that metabolite in blood samples. So maybe in the near future, some of you will get an email asking whether you would like to participate in such a study. We first want to test this in healthy human volunteers, because as you will all agree with me, horses and mice, they are not humans, so we first want to see whether in healthy people the levels of this metabolite go up after exercise. And the first point I already discussed with you, that we also want to know whether this really is good enough to prevent the disease progression. But I think the first set of results is quite encouraging. Yeah.
How long does it stay up?
Yeah, we didn't test that yet, but it's the half-life of this molecule is not very high, not very long. But others have found that you don't need to have the pyrophosphate levels being high during the entire day. Some people even think that during night, also in healthy individuals, pyrophosphate levels go down. And apparently, you only need to increase it a couple of times a day maybe, or maybe only once a day to prevent disease progression. But that's definitely something we also need to look into, because this is a modest increase in pyrophosphate levels, so that's why we also need to check in these PXE animal models to see whether it really does something with the ectopic mineralization. Because if it only increases pyrophosphate without doing anything with the disease progression, then it's not a useful therapy. On the other hand, exercise is good for you anyways, so it won't harm you.
So you might want to do it every day as opposed to twice a week.
Yeah, exactly. Maybe just short bouts of exercise are better than 2 times running for 2 hours, for instance, or 1 hour. Oh.
I mean, small ones.
I personally think, but I'm not someone that's an expert on this in this field. I'm just a vet. But I would think that using as many muscles as possible is probably best. But that's something that needs to be sorted out. Are there any other questions, or if not?
So this is
Oh,
the
sorry.
liver, right? I'm sorry. Does it happen in the liver? Do you want to stimulate this?
No, it's not in the liver, because this is in the red blood cells. So we have a lot of red blood cells. So the problem with PXE is not that there's not enough substrate to form the pyrophosphate, because ATP, it's a highly abundant molecule. It's very high in every cell in your body. The only problem is getting it out of your cell to be converted in this mineralization inhibitor. So we are now looking into ways in getting it out of the cell and having it converted into this mineralization inhibitor.
We're good?
Yeah.
Great.
Yeah, I'm good.
Thank you very much, Koen.